This lesson is being able to determine linear versus nonlinear functions. You should have done your warm-up already. If you haven't done so, please pause the video and complete the warm-up and have it checked. Your learning target. I will be able to determine characteristics of linear and nonlinear functions in multiple representations. So we're going to look for characteristics to use to identify if a function is linear or nonlinear in different types of representations. So the different types of representations we're going to look at graphs. We're going to look at tables, sequences, and equations. So let's take a look at graphs first. We have linear versus nonlinear. So we have a down the side. So on the linear side, we can see that all of our graphs are a straight line, nice and straight. There's no deviation from that. You've done a lot of graphing of linear lines so far. So these are in the form y equals mx plus b. Nonlinear functions are always going to have some sort of curve to them. Okay? And we have a curve to them. This one has a curve. Or they can have straight lines, but they're not at a constant rate. So they go up at different rates. So this slope, say this slope is 1/2. This slope might be 3. And this slope might be 1/4. So our slopes are different at different points in the graph. When we look at the linear, our slopes are always the same. In this case, we're going up 3 and over, or up 2 and over 3, the whole graph to get new points. Okay? That's it, graphs. So they must be straight lines. Nonlinear will have curves to them. When we look at sequences, we have linear versus nonlinear. And when we do this, we want to look for jumps. So meaning that from 2 to 5, we add 3. From 3 to 8, or 5 to 8, we add 3. And 8 to 11, we add 3. Here, we're subtracting 6. Every jump, we're subtracting 6. Would you agree? 1 minus 6 is going to give us a -5. That's this value. And if we subtract 6 more, that's going to give us a -11, which is right there. So we're subtracting 6 at each jump. On this third one, we're going up. How do we get from 4 to 8? We add 4. How do we get from 8 to 12? We add 4. And so on, each time to get to our new value. Down here, we're adding 2. So the jumps for linear, jumps are always equal. In the nonlinear, your jumps will be sporadic. So there will not be any consistency to them. So if we look at here, 2 to 4, we're adding 2. But from 4 to 8, we're adding 4. And from 8 to 16, we're adding 8. And from 16 to 32, we're adding 16. So it's not a constant jump each time. Let's get another one. We're adding 3, but here we're adding 5. Now we're adding 7. Now we're adding 11. I lie, 9. We're adding 9. So each jump is a little different. So that's what makes it nonlinear. The jumps are different. Here we're subtracting 5. Now we're subtracting 10. Now we're subtracting 15 and subtracting 20. So that's what makes it non-linear. In tables, we're going to do the same thing. We want to look for those jumps. So we're going to look at the output values. Those output values are your y values. Another word for that is your range. What do we call the x values? We call them the domain. So from -7 to -3, we've added 4. From here, we're adding 4 again. So every jump is 4. Let's look at a nonlinear one. Here I'm adding 4. Here I'm adding 5. Then I'm adding 6, 7, 8. So my jumps are not consistent. They jump by a different amount. That's what makes it nonlinear. Take a second and find the jumps for the other 4 tables. Pause the video to do so. So you should have taken a couple minutes to find the jumps for the last 4 tables here. You'll notice that in this linear one, our jumps are 6. That's why it's a linear function, because it's jumped 6 every single time. This one, our jumps are -2, so subtracting 2 every time. They're the same value. That's what makes it linear. On the other side, the nonlinears, these jumps are all different. That's what makes it nonlinear. These jumps are all different. So we even have a no change in one of the jumps. It stays at 0. So that's nonlinear. In equations, we're going to look for different things. In linear functions, we're looking for that form y equals mx plus b, or they could be put into that form. In nonlinear, we're looking for things that cannot fit into the y equals mx plus b. So if we look at this one, y equals mx plus b. Well, our m is -3. So we're looking for that in every single problem. So here, we know that this is a horizontal line that has no slope. So that's a linear function. This can be put in that form, y equals mx plus b. And this could be put in that form, y equals mx plus b. We could have something like this, 3y is equal to 2 minus 5x. That still can be put in that form, y equals mx plus b. The y and the x are separated, so this is a linear function as well. Nonlinear. We're looking for these exponents. We don't like the exponents, or the x's, the variables, to have exponents. So we're looking for those, no exponents. If the variable is the exponent, we don't like that. Or if this one, I'm going to rewrite this so it looks a little different, 5 divided by x, we don't like those x's to be on the bottom. Okay? They can't be divided by those variables. Another way nonlinear would be if we had something like this. 3 is equal to y times x. The variables can't be multiplied together. So it's okay for them to be subtracted. So y plus x equals 3, subtracted or added, but it's not okay for them to be multiplied. So that's what makes things nonlinear versus linear. So things to keep in mind. A table is a linear if the rate of change is constant. There's a common difference. The change is the same. We like those straight lines. Okay? That's what this graph is. It's a straight line. There's no curves. In an equation, the linear is the power of 1. So x, this is a power of 1. X squared, that's a power of 2. So this is linear. This is nonlinear. Appears in the numerator. So x divided by 2 is okay. That's in the numerator. But if it's 2 divided by x, that's nonlinear. We don't like those. Now complete the your turns and have them checked. If you have any questions, please ask.